Good. So we continue with the lectures. This part is about architectural requirements analysis. When we categorize the architecture design methods, one of the key processes, first processes we saw was requirements analysis, architectural requirements analysis. So that's the topic of this presentation. We'll first look at requirements, look at requirements specification techniques, and the requirements engineering. So the model, the specification, and the process, the techniques, the methods. Requirements analysis in the life cycle, of course, it's the earliest process in the software development life cycle. The software development project starts with some requirement specification provided by somebody. This is a definition of requirements. So what is a requirement? Requirements are the statements that identify the essential needs of a system in order for it to satisfy customer needs. The customer's need might be to solve a problem, achieve an objective, satisfy a contract, standard, or specification. Now, if we look at this in detail, this definition, could we say that something is missing here? That's maybe what is missing or incomplete in this definition. Architectural requirements we are talking about. Identify essential needs of a system to satisfy customer needs.
Not just the customer needs,
So,
also for stakeholders.
right. So we could say actually it's not architecture is the result of taking into consideration the architectural drivers. Architectural drivers are the result of the architectural stakeholder concerns. So we should also take into account multiple stakeholders. We might maybe need to reformulate this as the stakeholders need. Okay. What is a stakeholder? An individual, a team, organization with interests in or concerns relative to a system. Okay. So persons, teams who have interest in the system that we are going to develop. What are these persons? The roles actually: manager, designer, programmer, architect, integrator, end user, customer, etc. Okay. We have architecture. It's described by architectural description, consisting of models, and the architectural description is relevant to a number of stakeholders. This was a slide from the previous lectures where we said that stakeholders have one of the key impacts on the architecture. We have multiple stakeholders, they have different concerns, and very often they can also be contradictory. And the architect, it's the architect's roles first to identify the stakeholders, identify their concerns, and where possible also resolve the conflicts. So we say these are the architectural drivers. Architectural drivers, as we said, can consist of high-level functional requirements, technical constraints, business constraints, quality attribute requirements, and these stakeholders, all the stakeholders define the drivers. They are processed by the architect or architect or architects, the architectural team, which define some design decisions, and in the end we get our architecture, software architecture. So one of the first issues in requirements analysis, architectural requirements analysis, what's that? So what's very well thought. We have first to identify the stakeholders. Because stakeholders define the architectural drivers. So then it's key to the architectural drivers are the essential concerns. So then it's key to identify who these persons are. So how to identify stakeholders? It's not an easy process, but you should think of basically from a role perspective. I have some system. What are the roles played in this system? It's not necessarily a person, a physical person, but a role. So we actually identifying stakeholders means identify the roles that are assumed to be used in that system. Okay. A role can be fulfilled by multiple persons. Okay. So it's a end-to-end relation. Okay. Person can have multiple roles, and the role can be fulfilled by multiple persons. So we should look at the roles. What are the roles that are important in the application? The IEEE 147 is a standard, it's a recommended standard on architectural description. It indicates that the following minimal set of stakeholders have to be identified, defined. Users of the system. Of course, you have a system. What's the role? Well, somebody has to use it. Customers of the system. Somebody has to pay for it, right? Developers of the system. Some teams should develop it. And maintainers of the system, because change is permanent. Systems are not, we don't just develop and then it's done, but actually most of the work starts in the maintenance process, so we need maintainers. Yeah, there's some logic here. If you look at ATM, the famous ATM example, which is in every object-oriented design course, probably. What are the stakeholders here? So we should think of the roles of the ATM. Bank customers, right? Representatives of other banks could be stakeholder. Bank managers, counter staff, database administrators, the security manager. Security is an important issue. Marketing department. How should you the market? The hardware and software maintenance engineers, banking regulators, etc. Developers, testers. So we think of the roles in our mind. We have ATM. Who is probably interested in this ATM? Okay? Stakeholders. Well, let's look at this. It's a requirement specification, initial, for driver monitoring system. The system will be an onboard automated diagnostic system that will diagnose the driver and the car performance and provide the driver with appropriate feedback. So you have some system in your car. It analyzes your behavior of the driver, but also of the car. It's onboard diagnosis. The system will monitor both the human and the car. The human can be diagnosed based on physiological behavior such as heart rate, blood pressure, eye movements. Okay, it checks your systems. The car can be monitored against its performance regarding fuel consumption, acceleration, oil, state of the brakes, etc. Based on your diagnosis, the observation, the system observes the driver and the car. Feedback is given on a display on the dashboard. You see, you have high blood pressure, so you have to stop. Okay? Could be right. Or your eyes are closing. You are sleeping, right? It gives alert. You think out loud. The feedback can be based on red, green zone displays or multifunctional displays. So design the architecture for this, the system. In the software architecture design process, first, architecture requirements analysis. What is the first process in architecture requirements analysis? Identifying stakeholders. Okay, now discuss or shortly think about it, what the stakeholders are. What are the stakeholders? We can maybe discuss directly. Driver, yes. You see, the user, if you take just the IEEE Standard 4, every system has user, if you consider that as given. Who's the user? The driver. So for every domain, the user can be also have a different name. Driver. Who else? Maintainer. Right.
Repair and control.
Repair and control, it's right, it's related. What else? Maintainer. Okay. Only these three, and then we design the architecture. Sorry?
Programmers.
Programmers, yes, could be. They are stakeholders. What else? Car company.
Designers.
Why is car company important? Car company.
For budget.
Sorry?
The engineers, I guess, the machine engineers designing the car components.
They have to decide whether they integrate in these cars and how it fits. They are the stakeholders. What kind of system are you providing us? So you see, on-board diagnostic system. Okay, you have designed that system, but it doesn't fit in my car. I don't buy. Okay, designers, you said. What else? Sorry? Police. Yes, it's a good one. Yes? Why?
When you fell asleep or made an accident, the system can contact the police or hospital or something else.
Right, that's from the right, the positive perspective. Insurance company. Why? It's lowering the risks. Right. They could say if you have such a system in the car, it can lower. So then the idea is...
Can stakeholder be a system?
Stakeholder is a group or a team or person, a role, which has a role. If anything has a role which interacts with your system, it can be a stakeholder.
I think it's a, for example, car can be the system's stakeholder. Diagnostic systems stakeholder.
Actually, we define such issues in the context diagram. You see, there we had the context diagram. But if we talk about stakeholders, they are the person who we can just grasp and talk to, interview. Government laws, right? Could be. Sorry?
Gas station.
Gas station, why? Okay, so this discussion also reveals that there are important stakeholders and less important stakeholders. That's also the role of the architect. Identify, list all these stakeholders, and then prioritize also these stakeholders. gas station is stakeholder, you could say, but the car company is more important for me, you could say. The government, the laws are very important, so highly prioritized. Okay. Good. So that's the thing what you do. We will also apply this in the project. This will be the first process. This is a joke, so for me, which is on the internet on several sites. So I want something to get me across town in the shortest time. Then you get this one. I don't want to get wet, so he comes with the bike. And how am I going to carry my briefcase? So it repairs and then comes with an umbrella, but the idea was actually a car. This is already the problem of single stakeholder, and we have to actually, if we design architecture, we have to take into account multiple stakeholders, multiple concerns. It can easily lead to a system which doesn't meet some requirements of some stakeholders. So it is important to identify the stakeholders, identify the most important stakeholders, identify their concerns. So typically what do we do with stakeholders? We need to actually requirements. Okay, what are your requirements? What are your concerns? There are two types of requirements. Functional requirements, and also very often people use the term non-functional requirements. I tend to use quality requirements. And also in quality requirements, sometimes you have a distinction between external and internal requirements. External are visible to the end user, understandable, robust, correct, usable, reliable, and internal, reusable, maintainable, portable, testable, adaptable, etc., etc. All the realities. Besides of this, so we have domain requirements, requirements that come from the application domain, which we cannot find actually by just maybe interviewing some stakeholders. Domain requirements, for example, diagnostic systems. There are some requirements to develop the appropriate diagnostic system, the online monitoring system. This might include functional and non-functional requirements, constraints or on existing requirements, and typically these kinds of requirements are elicited through a domain analysis process, which we will explain it in a separate lecture. Domain analysis. So requirements identify stakeholders, all the concerns, etc. But we are aware that there are also some requirements which are just part of the domain. And that we should do in domain analysis process. Like we prioritize the stakeholders, we have also to prioritize the requirements. Why? Some requirements might be more important than others, so there's some degree of importance for each stakeholders and each requirements actually. Even at so stakeholders even at the larger abstraction level, but stakeholder can have multiple requirements, and requirements of different stakeholders might conflict with each other. Might have different degrees. Conflict is the next slide, sorry. So as such, it is important to also rank these requirements. So you could say these are all my requirements, and then define the priorities. These are the essential requirements, let's say, the requirements which must be supported, which are mandatory. Okay. Some conditional requirements which might need to be which can be supported for some condition, for example, for the next release, and optional requirements. You can support or not. So what you do is you actually talk to the stakeholders, you prioritize these stakeholders, you identify their requirements, and then what you should know is this an essential requirement or is it just optional? How important is this for you? Okay. Then there's the conflicting requirements. So requirements can conflict. You will have multiple stakeholders, multiple requirements, and typically there can be some relation between these requirements. If there's no relation, then we say there's no dependency. Some requirements might require other requirements, right? Or they might also be conflicting. For example, reuse, the concern reuse might conflict with time to market. You would like to actually design your system such that it's very reusable. But time to market means that you have to deliver it in time to the market. Otherwise you will lose your customers. So you don't have time for reuse. So the requirements could state it should be a reusable system. One of the stakeholders would say that. Another stakeholder, or even worse, sometimes the same stakeholder can say that. You should deliver it quickly to the market. So time to market should be high. So hey, these are conflicting. Okay? So you should identify these conflicts. Adaptability versus time performance. The system should be very adaptable. But also it should also react very quickly. For example, in our case, to the eye movement. In general, adaptability conflicts with time performance. Because adaptability, we should make more components explicit. There will be more redirections. Okay, there will be more loosely coupling. With time performance, you have more inlining. So that conflicts. So it's the role of the architect also to, after prioritizing the requirements, to define these conflicts. So what would you do if you have a conflict between so requirement 1 is highly important, but it conflicts with another requirement which is not that important. There's a conflict. How do we resolve?
Ignore the less important one.
Right, we just say we take the important one, this conflict, but we don't implement. Right? So things will be more difficult if they have the same importance, the same priority. They are both essential. Okay? And it's not an easy job actually. There's no simple solution to that. What you have to do is discussion with the relevant stakeholders. That's necessary. Try to come up with solution scenarios and define the appropriate trade-offs. So you have to define the feasibility region in this conflicting space. That's one. Okay. So we have to identify these stakeholders, prioritize these, identify the conflicts, and then actually you have the notion of software requirement specification document. We have to document these. Okay. Well, just document where all the stakeholders and the requirements are explicit. The benefits, of course, it provides an agreement between the stakeholders and suppliers. The reduced development effort, you can, based on the requirements you can develop, provides a basis for estimating the costs and the schedules. Provides also baseline for validation and verification. Using the requirements, you can actually validate and verify, facilitate transfer to new users or platforms, and serves as a basis for later enhancement of the product. Given the initial requirements, then you can know what to adapt. There's the an IEEE Standard recommended practice for software requirements specification. It's a document which describes content and qualities of a good software requirement specification, provides sample software requirement specifications, outlines. You might look at this to structure your requirements document. This again from the same document. What are the characteristics of a good software requirement specification? So once you have defined it, they typically define these properties. They should be correct. It should be include the requirements that the software shall meet. Unambiguous. It should every requirement in the SRS should have only one interpretation, which is not easy. Complete. Should include all the relevant functional and non-functional requirements. If you have missed some stakeholders, then it of course will not be complete. Should be consistent. Try to avoid conflicting requirements. Prioritization of the requirements. Should be verifiable. Should be able to check that the software product meets the requirement. Modifiable. The requirements specification document should be so structured in such a way that you can easily adapt the requirements. For example, if you have nicely separated the stakeholders, then it's easier to change the requirements for each stakeholder. Traceable, if it defines the origin of each of the requirements. This is of course also a wish list. In general, it's not easy to achieve these goals, especially if you want to achieve both completeness and consistency. So it's required, the document, the requirement specification document should be complete and consistent. Should include significant requirements, there should be no conflict. This is of course hard. Right? It's very hard. It's related to also no single system can be complete. If a system is complete, it will be inconsistent. If a system is inconsistent, if it's consistent, it cannot be complete. Gödel's theorem, right? It's just it's related somehow. Because it's not black, it's not a closed world assumption, but it's open. Okay, let's look at some requirement specification techniques. Actually, I think most of them you know. These are the current techniques for just textual requirement specification. Use case diagrams, scenarios, or user stories, they also say. Constructing a prototype, user interface prototype or a general, and defining state diagrams. Textual requirements, just a document in natural language, like this, or also more formal, more structured. And as I said, you could also look at the IEEE standard on document and requirement specification. Typically, in our case, it is important to identify the stakeholders, their requirements, and also define the priorities. And after this, you could have a section where you identify the conflicts and how you tend to resolve it, also later on. without providing the solution, of course. Use case diagram. This is used a lot in object-oriented design, in the requirements analysis. You have a system, an actor outside of the system, and some use cases that the end user can interact with. Can we use use case diagrams to describe any requirements of all stakeholders? Why are use case diagrams limited if you want to describe the stakeholder requirements? Stakeholder in general. Who? Why is it limited? We said so. A key issue is to identify all the stakeholders. So we can define textual requirements, right? Like here, stakeholder. And we can also, second one is use case diagram. Why is this limited?
You can't show the conflicts.
You can show the conflicts, right? But even before that,
Every stakeholder is not directly linked with the system.
right. This is actually the, what kind of stakeholder is this in general? In general, it's just the user, end user, how it interacts with the system. How do I define here the tester? Hard, right? Maybe I could have a test case, test, but it doesn't reflect the property. Or maintainer, or manager, the government, right? There's another reason why this is somehow limited. These use cases are basically functional, right? So what's limited? Non-functional, right? How do you define here the adaptability requirement? See? So it's actually, these techniques are complementary. So we use textual requirements, we use use cases. This is quite nice still because it defines the context. It's quite understandable. But usually you use several techniques. This is the third one, where we can define the scenarios, user stories. What's a scenario? Brief description of the desired and or anticipated use of system. For example, these are 5 scenarios: monitoring of driver behavior, monitoring of driving performance, car performance. You could have also more detailed scenarios where you explain actually the story on using the system, which could be more expressive than just the simple use case. In this way, it's almost similar to use case, but it could be a complete story. Okay? And of course, one important issue is change scenario. This is the requirements analysis. This is the stakeholder. Are you interested only in monitoring for onboard diagnosis? What are your expectations? How will your business evolve? Could be an interview, right? We will first start with the pilot study. Later on, we may evolve the monitoring system for routine and special maintenance, remote monitoring, driver training, and certification. See, we cannot easily capture these in use cases. Okay, then you define more like scenarios. Scenario 1, in due time, it will be, they will use remote monitoring. Prototypes is also used a lot. Before you develop the real system, you define a prototype of the system. Prototypes can be, if I say prototype, so it's not only just user interface prototype, it's used a lot, but could also be just a prototype of the system to show how the system behaves. Okay, could be even without a user interface. Okay, some prototype, prototypical system. It is often a user interface prototype. There you have throwaway prototype, distinction between throwaway. Throwaway prototype is just for eliciting the requirements. You define some diagrams, user interface. I see, okay, and then you throw away. The other is evolutionary prototype, where they keep the prototype and increment the prototype to develop the eventual system. This is another technique for defining requirements, architectural requirements. In our case, we could just develop such a prototype, user interface prototype. It was about a feedback system, so it's quite simple, of course. Driving behavior, then we have some bar here, so 3 properties: steering movements, brake maneuver, transmission, car performance, fuel consumption, oil brakes, some graphs here and then. Then you just show this to the stakeholders. Is this what you mean? You could say, this is not what I exactly want. I also need functionality for actively guiding the driver, etc. This is too simple for me. It's not what I mean, etc. See? So it helps it helps to identify the key concerns. Then we have the notion of state diagrams. It's also used in the requirements analysis, especially for safety critical systems. It really makes sense to define the requirements as a set of states. So this could be state transition diagram for monitoring. So it could be imposed. These should be the states. After the car is idle, if you start the car, the system should be active. And if the car stopped, it should stop. It's a requirement, right? And in between, you can just press some button to stand by. Just a simple example to reflect the requirements, to help you to identify the key requirements. Okay, these were the techniques, almost done. What's the process? Actually, there are 3 basic processes. I just go actually correctly through the requirements analysis process. It could be a course by itself. There are several courses on that. But here we just focus on the key elements. In the requirements engineering process, there are 3 basic processes: eliciting requirements. From our perspective, identify the stakeholders, identify the requirements for the stakeholders, analyzing requirements. There you check whether the requirements are complete, clear, precise, etc. And finally, you specify in the SRS document. That's what we will do in the project. Usually, interview technique is important in software requirements engineering process. So in a typical architectural design process, you identify the stakeholders, the roles, and then what you should do is actually for each role, identify the person which has that role, and then actually organize a meeting, an interview meeting, to discuss the concerns. Okay, you make a schedule. Okay, Monday, interview with the manager, designer, the tester. Okay. You could have 2 types of interviews, closed interviews, where you could have a predefined set of questions. Could be related to quality, to patterns, whatever. Open interview, where you just go, I have a meeting with manager, you just take notes. It's all part of the architect's role. In practice, you have a mix of closed and open-ended interviewing techniques. Of course, if you have, the more experienced you are, the better you can define the questions. So you could have closed interviews. Interviews in practice are good for getting an overall understanding of stakeholder concerns, but for domain requirements, as we will see, we have to do also domain analysis. We have to investigate also the domain which is related to our system. There are some problems of requirements analysis which you will also encounter in the project later on, or reflect on, not encounter. Requirements might not always reflect the needs of the stakeholders. Sometimes stakeholders do not know how to express their concerns. You could have conflicting requirements among the stakeholders, and stakeholders, the needs, the requirements change over time. New stakeholders might even emerge in due time, so you have to take that into account. Summary. Requirements are statements that identify essential needs of a system in order for it to satisfy stakeholder needs. So architectural design process, first process requirements analysis, first sub-process identify stakeholders. Why stakeholders define the architectural drivers? They will shape the architecture. Usually they have a different degree of importance, so we have to prioritize these. But unfortunately, stakeholder requirements might also conflict. So also an important process, a role of the architect is to resolve these conflicts. These all you should specify in this software requirements specification, which can include different, in which you can show the requirements using different specification techniques. Requirements engineering process, if you do the process which results in specification, includes the elicitation, requirements analysis, and specification. And that's it for the requirements analysis part. Any questions? It's quite clear, right? This is also the first process in the project. Okay? So you have to also, I will explain the project description on Wednesday, but you have to define your own case and also follow this process. See you on Wednesday. Thank you very much.